Hi everyone. Today we'll be doing lecture number 4. That's basically a continuation of what we were doing previously. We basically doing the conditional statements involve if mostly. So here we'll basically also continue from the very last part we're dealing with. That's the loops, the looping structures. In this case, we're just dealing about while loop. And if you remember, the while loop is just a structure or it's basically a keyword that will go through a piece of code as long as a condition is met, right? So basically, like here, while we have item in the shopping list, then purchase the next item and cross it off the list, right? So if you have some items in your list, then you want to go through all of that, and then at the end of the list, then you would basically stop. A while loop is basically working this way. You have your while loop here, and then you have your condition statement, like x should be less than 1, or maybe, I don't know, you set your condition right there. And you have your statement, your bunch of statement on this side that will be looped as long as the logical expression is true. This is the basically the solution to the problem that has been given to you on the previous lecture. For those who didn't understand it, then we initialize the first row to be 1, to be the number 1, and then while the row, right, the row is less or equal to 9, means that we'll include 9 into our iterations. Then we set the column to be 0. Remember, when we started this course, we said that we should start from 0 for us to count. And we have another looping structure within the first loop. In the next few slides, we will call it nested statement. Then you're saying that as long as this column that has been incremented here, as long as that column is strictly less than this row defined here, then get in here, print that number, do not leave any space between this row and the next one, and increment column by 1. But if we speak about 1 basically, if you increment 1, like we already printed 1, this is 1 printed, and if you add 1 to here, we'll go up here and we'll be having 2 less than 1, which is false, right? And then we print an empty something, then we leave this line, and then we increment row, and row will end up being 2, and we basically in the second line here. So that's how this code works. You can have multiple solutions of the same problem. It will be accepted, but then as long as you understand what's going on. More on loops. You saw in the previous slide that we have a while loop and another while loop under that. So we call it nested loop. It's a nested loop, but then in computer science we call it nested structures. So it's a structure within another structure. It can be while loop up there, and then we have an if statement, and then we have another while loop, etc. So here you are given an exercise to do. Unfortunately, not in class to do this type of things, but I'll give you a very quick pseudocode of that. So basically, you are asked to count the number of students who have passed in a class of 10 students, and if you have 8 students who have passed the test, then the lecturer get the bonus. And there's a bunch of things that will go through here. Since we're saying we're getting 10 students, since we didn't do list, then we will prompt the user to enter the students and the mark. As we're prompting the user, we're counting the students, the number of students who have a mark greater than 50% if it's that the pass rate. And if that number, it's like while while basically we getting the numbers into our system, we counting them, and while we counting them, we getting also their mark. And if the mark is greater than the pass mark, 50%, then count the number of those students who passed. And we have another one. If the number of those students is greater than 8, then bonus to the lecturer. That's basically what you need to write in Python code. So this is your high-level pseudocode. As you can see, it's not very different from what I have been telling you earlier on. So you have to initialize your variables. We basically speak in Python here, but on the very top level, you have to analyze the results and decide if the lecturer should get a raise or a bonus. But then when we go to Python, you initialize your variables. You can have your count variable, you can have your mark variable, you can have I mean, many other variables, as many as you want, but the most important here is the count. Some student would say, while count is less than 10, means that count will start by 0. While count is, some other people say, while count is less or equal to 10, then your count will be 1. Then you input the 10 grades, and you count the one that have passed or failed, and you show whether the lecturer should get the bonus. Also, not a high level, but it is lower level than the pseudocode we saw earlier, and it describes exactly what we were speaking about. So you have the slides, and you will go over this pseudocode as you read the slides. I will not spend too much time on this. And this is the Python code where I will not also spend time on that. You can see that there are very, very big similarities here, but you see your while loop, you see your if statement, you see your else statement. They all, if and else are fine. This is an if else statement, but then they are all nested to this while loop, right? And the pass mark is 50, and you have all of your variables that go there. It should be alright. If you have a question, please let me know. Okay, now we have another type of loops we call the counting loops, right? The previous type of loop, you're having a for loop, like as long as a condition is true, then run the loop. But then in this instance, we have a different type of loop where we control almost how the loop works, right? So in this case, we have 3 parameters that we need to set to that loop for basically for it to work. The very first parameter is the initialization of the counter. You tell the looping structure what's the first variable, and then you tell basically where does it start from. Does it start from 0? Does it start from 1? You tell it straight from the go. You have your termination condition. It's basically the same condition I would put in your while loop, right? That's your logical instruction or expression. And then the modification of the counter, we usually call it the update. That will tell the looping structure how to step from one level to the next one. Cool. And this type of condition I usually call the for loops. So you can see here in your while loop, the colors are matching, right? So we have our initialization here, where we initialize stuff outside the loop here. We initialize our things here in Python, right? Where we have our logical expression. Here is our logical expression. 0 should be less than, from 0 to 10. And then we have our update here, which is 1. So how will the number of students will move from 0 to 10, then it will take a step of 1. Here it will increment by steps of 1. And all of them are bundled into this for instruction. But then in this instance, we have number of students which is outside, we have number of student increment which is somewhere there in the code. So yeah, it's basically very convenient to have a for loop. Yes. Basically a for loop in Python doesn't can come in multiple fashions. Like you have for this instance for x in a range of numbers, we have the start of the range, we have the stop of the range, and then we have the step, right? Basically how the numbers live from start to stop. And remember that this stop is never ever reached. We never reach that stop number. So that's basically how it works. You see here we exclude the stop as we go through this list of numbers. Okay, so here if you don't put any start, the default number here will be 0. And we'll see that in the examples here. We have from 0 to 3, the step is 1 is 0, 1, 2. The range of 5, 0, 1, 2, 3, 4. From 0 to 10, step 2, we have the even numbers. From 20 to 25, 21, 22, 23, 24. From 5 to 2, we decrement by 1. So that's how those things work. And you can see that range with length into what we call a list, something with those brackets, but we'll speak about that later on. Those loops are special type of structures in computer science that we like a lot, but they usually come with these other type of instructions. Like here we have break statements. A break statement, it's some keywords in most of the languages that you will encounter in your future, where that says that okay, fine, we're looping through a set of numbers and we're doing some instructions right here. When we encounter break, get out of the loop. So whatever, like even if we were having a forever loop here, when we hit the break keyword, then the loop just ends and then we carry on with the code that's outside the while loop, right? Here, like as long as it is true, we will just keep on printing. This is what this thing will do. But then as long as it's true, it should print. But then if I is greater than 10, then break, get out of this loop and carry on with the code. Continue is, it's not doing the opposite of what break does, but then it's okay. Continue takes an iteration, right? And you loop through some numbers, like for I in range 10, it's like we'll actually go from 0 to 9, print I. But then when you have a continue statement, what it does is like when he hits continue, the iteration will basically not the computer will not go after the instructions that come after continue. Sorry for my language. So the computer will not execute whatever is after continue. It will skip all of that and then it go to the next iteration. So while I is equal to 5, it gets in here, it will not print 5, it will go to 6 and it will print 6. So we'll technically have 0, 1, 2, 3, 4. We get to 5, we skip 5 because continue is there, 6, 7, 8, 9. That's how it will work. But common errors that I saw in those two, especially in break, while you are asked to tell what break doesn't stop the entire code. Break just stops the loop. And if there are some other lines of code after that loop, like in this line, because if and print are within the loop, there are some codes outside the loop, then that part of the code will execute. Cool. This is a homework that you need to do that almost looks like compound interest. You would need to use some looping structure to calculate this amount here. It's fairly simple. It'll be entirely up to you to know how to use your increase your n and your p and do all of those things within loops. Now we're going into some more complicated structures that we call lists. Lists are basically a set of things that live in the same environment. I would call it a little container, right? Yeah. So a reason why we use list, like reading 10 numbers, right? How would you do that and print them in the same order they were entered? What if you want 100 of them or multiple of them? Do we want to store them somewhere? Okay. Now, if you have just numbers, individual numbers going away this way, like it's not very good, right? You want to store them in a list, like in a variable that will hold basically all the other variables that go after that. There we coming to lists. Okay, lists are basically, they are built into Python, so we don't actually import them. Lists are it's a data structure that can contain variables, some other variables. And the nice thing in Python, they can contain any type of variables. In this instance, we have integers, boolean, and strings. As you can see, yesterday is a string. It's like, and it's a funny one. Okay, and also to initialize a list, you have two possibilities. Either you say list this way, or you can write an empty list, like this. Yes. Lists have multiple properties. Like when you define a list, you can do a lot of things with them. You can add something at the end of this list. Then we say we appending something to the list, right? We append Bruce Banner, we append Bruce Wayne at the back of the list, right? The very first one, we put the first in, and the last one will be the very last of the list. Then we have all this other list here that has some names, right? The first list has Bruce Banner and Bruce Wayne. And when you use the keyword extend, then you're saying that, okay, I have a first list, I have list one, and then I would like to add that other set, that other list number two. Then you extend the list, right? Append just puts one item at a time in the list. Extend puts a list, it takes a new list and puts it at the back of an initial list. Cool. We can also remove stuff from the list, and that's up to you now to go and figure that one out. You can go and look at the Python API library so that you can understand the other properties of a list. The most important property you need to get from a list or any other container of this fashion is the indexing. Indexing is a way of getting in the list, accessing stuff from the list, right? So in this instance, we have colors, then we have red, blue, green, and any other colors you would want to store in that list. But then if I'm asking you, what's the second color? Then it's like, from our eyes, we can see that it's blue. But then, using a computer, you would say the blue color is at index 1, right? Because we start by index 0. Remember, we always start by index 0. So we have index 0, index 1, index 2. And when we say indexing, it's just a matter of getting in each and every of these lists. And you have your last property telling us what's the length of the list. It's just a matter of taking this keyword length in front of the variable which is the list. It will return you the length of the list. Cool. Here we have basically a way of, we can also loop through a list the way we are doing with a for loop with range, for instance, right? Remember exactly what I was saying about range. where basically range will end up being a list, right? Range of 5, which is 0, 1, 2, 3, 4, range of these ones, right? Then we're going to here, and then we have for I in this list. This keyword is just telling you that X will take each and every value of the list and then will be used in the for loop, right? This code is very self-explanatory, same as this one. Like for I in range of length of the number, this one means that for I in range length of this, the length of this is 3, and the range of 3 is 0, 1, 2, and then we'll count just that. Those two codes are doing the exact number, the exact same type of thing. But then this one is indexing directly. This is what we're using here, and this one we're fetching the number straight from the list. Enumerate, it's basically a keyword in Python. It's a very nice one where you're not only returning the value, right? You're returning the value and the index of a particular item in the list. So if you go back here, you have, in this instance, you'll be having the value number 5 for index 0, but then here we have no way of telling that it's at index 0. Same for the other ones here, right? Maybe here we can find a way to say, okay, cool, we were at index 0 because we know that it starts by 0 and then it will end by the length of this minus 1, which is 2. It start by 0 and the 2. Then we can work out the index. That's a lot of work. But if you really want the index of the value that you're pulling from a list, you would want to use enumerate, where it's okay, fine, we have Sansa, Arya, Brian, and Rickon. Then here, enumerate will return the name and the index of each and every item of this list, right? So that's it's a nice feature to have if you really need those two components. The in keyword, it's also very used in loops it's like when you want to check if something is actually in a list. Like that's why people are saying Python is so close to English. If you know how to speak English, then you know how to speak Python. That's literally that. Yeah. So what in will do, it will basically take this keyword, jump into this list, and it's like ask, are you this? Are you that? Are you that? Right? It will basically loop through that. It will do that job for you to see if that one is basically in there. And if it's in there, this one will end up being a logical expression that should return two values which are true, either true or false, right? In this instance, like if aka in the concert lineup. Now, like, let's unroll this one. Is this guy aka? This is Casper. This is aka. That's not true. This is aka. This is aka. Then that is true. And since it is true, I'm not going to that concert because aka is in the lineup. That's literally what this code is doing, right? It's a very nice feature to have as well. Cool. Lecture number 0 to lecture number 3, I'm sure you have seen the data types, and one of the data type that you encountered are the strings. A string is basically a set of characters bundled together to end up being either a word, a phrase, a paragraph, a text, whatever. But in Python, you can index, like Python strings have some properties that go alongside with the other programming languages of the definition of strings. But then there are some little differences. A string is a list in Python, right? It's a list of things. You can index a string. So item number 0, 1, 2 will end up being E. you can append, sorry, not appending, but then you can basically put two strings together, right? It's like we'll be having Glen Coco. But then I wouldn't call it appending, but then that's putting at the back of a string. But when we say appending, it's that keyword. Like if you look at this one, a list we can index, right? We can index in strings as well. But then we cannot append. Like if you take append and then you put it in a list, you cannot do that. You cannot assign. Assigning means that at index number 2, if you say, okay, I don't want E anymore, I want I there, that also will not work for you, right? You cannot append, you cannot assign. This is the property of strings in Python. Yes. Now we are getting at the very end of the lecture here, and you have your homework here. It's like for those who watch these. Sorry, I totally forgot the name of this one. Game of Thrones. Yes. So for those who watch this, then you would understand exactly what this exercise is about. I will not spoil anything. I'll just leave it to you, and you come up with a solution, and we will discuss that either in the Moodle forum or the WhatsApp group or wherever you want to discuss that. We spoke, so at the end of this lecture, we basically spoke about looping structures like the while loop, right? How to get into a loop, what is exactly is a while loop, where we have a logical expression that needs to be true for the looping structure to go further. And to improve that looping structure, we said, okay, why aren't we adding some extra parameters? Those extra parameters landed us into the for loop. The for loop has 3 main parameters, right? You have your initialization of your variable, you have your logical expression, and then you have your updates, right? So, and when you have those 3 ones, you can better master the way your loop is going through. After that, we went through lists that can make use of, that actually make a very extensive use of loops, right? List is basically a data structure that keep primitive data in a single place together, right? In Python, list can be of any list can contain data of any type, and for you to get into those lists, you can either index, you have to index those values in the list to basically get those values. So that's the end of lecture 4. I'll be doing another video for lecture 5. Basically, like I said, feel free to ask me questions through mails, WhatsApp group. You can also speak to Steve. He'll be very happy to help you. Thank you very much, and good luck with your studies.